So, I welcome all for week nine's problem solving session for Learning Analytics Tools course. Okay, so we will begin the session as this is the time when we start the session at 7. Let more people come and join along the way, right? So, in the chat, I have shared the link to the Google Drive where I upload the notes which I used, or the presentations which we used during discussions in the class. So that has been pinned. So I hope that's accessible to everyone. You can go through all PDFs till week 9. So till week 8 the PDFs have been uploaded, and week 9 will be uploaded as soon as the session gets over. Yeah, so you can have access to this whatever scribbling we do along the way during these sessions. So we will begin with week nine's content. So we already saw the descriptive analytics, that is answer to the what question, what our data looks like. Yeah, then the diagnostic analytics, we changed to back. Yeah, then diagnostic analytics. Diagnostics helps us find the answer to the why question, that why a particular set of patterns are occurring again and again. Then what is the overall bird's eye view of the learning path of our learners, etc. So all these questions we can find answer to using diagnostic analytics. Then now, for past few weeks we have been doing is predictive analytics. We are trying to predict, and why we are trying to predict is so that we can take the proper prescriptive analytics to optimize the learning environment, to optimize the teaching learning practices. So basically it is like we take remedial classes only for the students who are scoring less in mid semester exams or unit test, so that they score well in the final exam. So same algorithm or same logic we follow for the predictive analytics. What we do is we try to predict at-risk student. We try to predict students who are going to pass, or students who are going to fail, or students who will be scoring below or above certain range, so that we can identify those students, or we can predict that with these set of features this particular student is going to pass or fail, so that we can feed that prediction to the prescriptive module of our learning environment, and then that prescriptive module can take care, or can take steps, so that that particular at-risk student doesn't remain at risk forever, or doesn't fail in our exam. That's the whole purpose of predicting, based on features. So if you remember, when we had seen data cleaning, and this particularly from the descriptive analytics week, so there we had also seen one term called feature generation. Features are some additional information which we some logical inferences which we try to draw for each individual data point. So raw data is often unusable. You cannot use the raw data, raw log data as it is. So we follow some process called feature generation, wherein we draw some inferences based on that raw log data, and that inferential information, which is constructed on top of that log data. Such information we call as features, and these features are used in these predictive algorithms. So in these this week we will be going through naive Bayes classifier and decision tree. So both of them are predictive algorithms. So what's the difference between them and the logistic algorithms which we saw last week is linear logistics assumes the linear relationship, whereas there are no such assumptions for naive Bayes classifier and decision tree classifier. Okay, so now, as the um, name suggests, that naive Bayes. So what happens in Bayes theorem is all of us might have seen or might have heard these word of Bayes theorem in probability, condition probability, right? Bayes theorem of conditional probability. So this classifier model is built on that same Bayes conditional probability theorem. So what happens is our features or our independent variables, they have certain values on which the dependent variable value is computed, that value is computed. Then what happens is that when there are multiple features, right, then those are the conditions. Yeah, when there are multiple features which help us in prediction of our dependent variable, then these are the conditions. Multiple conditions, there could be one condition, there could be two conditions, or there could be n number of conditions. So this probability value is calculated for considering all those conditions. That's why the Bayes theorem forms the basis of naive Bayes classifier. Yeah. So why it is called naive? Because there's a naive assumption that all the features are independent. Occurrence of all the features are independent. So in our case, can you tell me what could be the possible features based on students' log data? Yeah. So if we have some log data where students are accessing reading files, watching videos, going to the forum and asking questions, so these are certain actions which user is performing. So based on those actions, the number of actions, like number of times or frequency of those actions, right? Let's use the word frequency. The frequency of each action, yeah, though that would be feature. And in the classroom setting, for classroom setting, attendance, then their performance in projects, then their performance in assignments, their mid-semester marks, all these could be possible set of features for classroom settings. So why are we calling these assumption as naive is because all these may not be completely independent of each other, right? There would be some dependence of attendance and project, or project and assignment marks, and project assignment marks and attendance to mid-semester marks. So all these features are not completely independent. So that's why the name naive, and we use this formula for naive Bayes classifier as well. Yeah. So what we are doing is we are computing the probability for our target or our dependent variable, right, based on the conditions which are our independent variables, right? So what is this P A by B is? What is the probability of condition A when B has already occurred? So B has occurred in past. Yeah. Probability of A. So this formula is probability of B, that probability of B when A has already occurred, multiplied by probability of A overall, unconditional probability of A, and this product when it gets divided by unconditional probability of B, then that becomes a Bayes theorem. Yeah. So we will not be spending much time onto these formulas, because that formula, all those formulas in this chapter are very simple. You will have to kind of keep those formulas in mind. Sometimes the formula may not be given with the problem, sometimes it may be given with the problem. Yeah. You will be needing a scientific calculator, as scientific calculator is allowed for NPTEL exams. So right now for decision tree, I have not mentioned the formula here to avoid confusion, because for this week's problem solving we will not be using the decision tree formula for any of the questions which are there for current week. but it may occur that you may have to use the decision tree formulas also, the entropy and information gain formulas. So you have to kind of make a list of all the formulas and try to by heart those formulas, and that way you'll have to do. So so that that thing is clear. So for this particular chapter you will need scientific calculator. Okay, so if you don't own a scientific calculator, then for exam purpose, the final exam purpose, if you would be writing that final exam, then for that duration please borrow somebody's scientific calculator for going to exam, because if certain question comes from this decision tree, the entropy and information gain. Sorry?
They'll not allow the scientific calculator. It's available in the system itself.
In the system itself, yeah, right. So but if you don't know how to use it, then it's better to carry that. So just to be on safer side, I'm giving it. So but if you are, sorry,
it's easy to operate
easy
only.
to operate, great, then no need to look for another alternative. Yeah, so for decision tree, if you have any doubts for numericals, I would suggest please refer to the lecture videos. Sir has explained very nicely how to solve these decision tree numericals. Okay, so mostly the similar problems will be given in the exam also. But let me cover some theory part of decision tree which we will be using for solving these questions, right? So for decision tree, if you remember these words, Agnes or agglomerative clustering, hierarchical clustering, if you remember we had seen such trees. Yeah, so this is decision tree. The concept of decision tree is very similar to that of hierarchical clustering or agglomerative clustering. The going or branching mechanism, how to construct these trees, the mechanism or the logic behind that is very similar to how we do the agglomerative clustering or Diana clustering or hierarchical clustering, right? So the same problems persist here also, and the same logic goes here also in terms of how to start from the tree, how to start forming the tree, and when to stop the tree, you know. So as you remember in agglomerative clustering, at the bottom there were all the data points were considered individual clusters, you know. So the same thing happens while clustering decision tree. You will look for all the conditions based on the training data set. So all the machine learning algorithms, they require some training data set, so that their a model can be formed based on that training data set. Based on the features, they construct some model, which that same model will be used for predicting the testing data set. Yeah. So for decision tree, what happens is the training based on the values which are there in the training data set, it will try to construct such tree. It will try to accommodate as many conditions as possible, so that it has the correct classification, or all the conditions are taken into account while forming such tree structure. So in doing so, in doing so, what we end up doing is overfitting, that it will have 100% accuracy for training data set, because we are taking care of each and every minute condition, minute deviation in the values of feature, and we assume that such minute deviation at local level will, when we consider that, it will give us the optimized result. Yeah, so the optimization depends on at the minute local level, so hence it is called as greedy algorithm. Yeah. So these are the two problems with decision tree, that it is a greedy algorithm and it is it has the problem of overfitting. Then another drawback is when we are talking about so if you remember this Agnes and Diana also, they were working well for categorical data and not the continuous data. Like there have to be, if we have continuous data, then there has to be some conditions or some bins, like we used to do for distribution, that graph chart which we create for distribution. So in the same way, we have to convert that continuous data set into different categorical bins, the limited number of bins, that the if marks is one of the, or the performance out of 100 is our continuous variable data, then we will convert, or will break that range into chunks of marks between 0 to 20, then 21 to 40, 41 to 60, 61 to 80, 81 to 100. So we have 5 categories of for the continuous variable of marks. So likewise, there are ways to bypass this condition of that this particular decision tree algorithm will not be applicable for categorical data, will not be applicable for continuous data. We can convert continuous data into categorical values. So I'm getting some doubts in the chat box. What are the differences between naive Bayes and Bayes theorem? So Bayes theorem is the theorem which is used to calculate probability, but naive Bayes is a classifier which is a machine learning algorithm. So these are two different things. But naive Bayes classifier is based on the Bayes theorem, which deals with the conditional probability. So that's the difference between Bayes theorem and the naive Bayes classifier. Then overfitting means having many parameters used for decision. So overfitting is consider you going to tailor to get a dress stitched. Yeah. So what tailor will do is the tailor will take the accurate measurements of your body, your shoulder, your hand's length, everywhere, all over your body. They will take the accurate measurement, and they will tailor that cloth, they'll tailor that garment to be perfectly fit for you. So if I want to wear what is getting stitched, or what is being made for you, that garment, when I wear, it will not be perfect fit for me, because it is tailored for you. So concept of overfitting is when we give the training data set to a particular machine learning algorithm, that training data set, it comes up with a model which is perfectly suitable for that training data set. It will consider all the conditions which are existing in that training data set while coming up with this classifier model, the decision tree model. And when the testing data set, so that means the tailor has stitched that garment to your measurement, but now comes the testing point, which is me trying to wear that garment on myself. So I am the testing data set here. So that may not be 100% fit for me unless you and I have same measurement, right? So that will not be fitting for me if you and I have different measurement. So that's the overfitting. That particular garment has been overfitted for you, perfect fit for you. And in terms of machine learning algorithm, how we will say this thing is that this particular algorithm has the overfitting problem, that it performs really well for training data set, but there is no guarantee that it will perform well for testing data set. That's the overfitting problem. So having too many parameters in decision making is a correct way, but those parameters will be limited to the parameters which are existing in our training data set. Yeah, that's the implications of overfitting, or that's the condition which leads to overfitting, that these parameters which are present in the only in the training data set. Okay, so that's the problem of overfitting. So now how to overcome this problem of overfitting is we will be limiting the number of we will be limiting the number of conditions we are considering, or we will be limiting the number of parameters which we are considering for construction of decision tree. So since we are calling it tree, so one way of trimming the tree is by cutting down the branches or cutting down the leaves, which is also called as pruning. Yeah, so this pruning is the way in which we will try to limit the number of conditions, or will try to limit the parameters which we are considering while constructing the tree. So it's the one of the ways to overcome the limitations. First two advantages. Guideline for training and testing data sets. Yes, there are certain guidelines that there has to be enough training. So there are different ways. I think we had covered some type of training and testing data set in week 2 or week 3, I don't remember, but when we had done that ROC curve and the parameters, accuracy, then a false negative rate and false positive rate. So all that week, I think that was week 3 if I'm not wrong. So in that we had also seen some guidelines about training and testing data sets, different ways of testing your data sets, 10-fold testing. So it was mostly like n-fold testing. So in n-fold testing, what happens is data is divided into n equal parts, and one part is reserved as a testing data set, and rest of it is used as a training data set. So if I'm using threefold testing, then I will divide my data set into 3 equal parts. One part I will keep reserved, and I will train my model onto 2/3 of the data set, and I will test it on that 1/3, and then the middle 1/3 I will reserve for testing, and I will train it on remaining 2/3. So in round robin fashion, I will take care of all the data set, that all 1/3 portion of my data set acts as the testing data set, and all the remaining 2/3 in combination will be acting as a training data set. So this has already been covered in this course, okay, the guideline for training and testing data set. So standard practice is minimum 70/30, that 70% use a training data set and 30% you use as testing data set. So that's the general, if you don't want to follow the rigorous training and testing process. So coming to questions. So question 1, which of the following statement is correct about the decision tree? So we saw all the theory part or the points to remember about the decision trees. So based on that, please type in your answers in the chat box, that which option you think is the correct answer for this question, that which of the statement is correct about the so there could be multiple statements also, okay, so which are correct about the decision tree. So decision tree requires normalization of data. No, it works on categorical variable very well. So when we are dealing with categorical variable, it does not require normalization. So that's the so this is not correct. So then second, it does not require normalization of data. Yes, of course, it does not require data to be normalized. Then missing values are not important. It is correct, missing values are not that important, because whatever we have. So why this is advantage of decision tree? This is exactly desirable side effect of this problem of it being greedy algorithm. So being greedy algorithm, it will focus on local decision nodes, okay, and it will not be worried about what is happening at the bigger picture level. So that translates into, it is not worried about if some value is missing, but it will work with what is there, and it will not worry about what is not there. Okay. So decision tree does not have root node always. That's wrong. Any decision tree or any hierarchical clustering algorithm, they will always have a root node and the leaf nodes. Yeah, that's why they are called trees. And if there are multiple trees being used in our classifier, then it will be called as forest. So you would have heard the word random forest. So random forest is nothing but combination or collection of multiple trees. Yeah. So it will have root node, it will have leaf nodes, everything it will have. So for naive Bayes, these are the statements which are given to you, and you have to select the correct option about statement 1 and statement 2. So statement 1 says naive Bayes assumes independence among predictors. So what is predictor? Predictor is independent variables which we consider, independent features which are important part of our models. Yeah. Then statement 2 is naive Bayes can perform multi-class prediction. Multi-class prediction is considering the multiple conditions. Yeah. So both of the statements are true. Both the statement A is also true, and statement B is also true for naive Bayes classifier. So yeah, I got all the correct answers in the chat box. Option 1, that both the statements are correct, is correct. So now this is the data set which is given to us, and we are supposed to use naive Bayes classifier formula for next 2 questions. Yeah. So they have given us range and the count, the frequency count, you know. So in naive Bayes algorithm or naive Bayes classifier, this frequency count is plays an important role, because this is all what we are computing here is the probability, and probability is nothing but frequency divided by total number of samples which we have. Okay, so now the total number of samples which we have in this data set is 9. Yeah, and the total number of samples in this particular class where attendance is 40 to 60 is 5. In this particular class 61 to 70, this condition, there are total 3 students, and in these conditions the attendance between 71 to 80, there are total 1 student. So passed and fail. So this is the fail and this is the pass. Yeah. So now based on this table we are supposed to compute. I'll keep it like this. Yeah. What is the probability of student failing in the exam if attendance is 40 to 60? Yeah. So I will write down the Bayes probability formula. What is the probability of A if B has already occurred? Yeah, it is the probability of B when A has occurred multiplied by probability of A, independent probability of A, divided by probability of B. Yeah, this is the formula. So now probability of student failing, so student failing is the condition A, and if the attendance is 40-60, this event or this condition is B. So now with the help of this thing, this frequency table, we will try to compute probability of A, probability of B first, because these are all unconditional probability. Probability of A is student failing. What is the probability that a student can fail? So how many total number of students have failed is 4. Yeah, so probability of failing is 4 divided by total number 9. And what is the probability that a student's attendance is between 40 to 60? 40 to 60, 5 students. So 5 by 9, right? So now we will, so actually for this particular question you don't even need to apply the formula. We can actually tell from this frequency table, but I will, for for sake of understanding, we'll try to put everything in the formula. Yeah. So now one important probability we have to find is what is the probability of a student having attendance between 40 to 60% and failing. Yeah. So how many total number of students who have attendance between 40 to 60? It is 5. So probability of B by A is total number of students who have attendance between 40 to 65. Out of them, how many have failed? 3 have failed. Yeah. So these are the value. We already have the values, so now let's put all the values in the formula. So yeah, so 40 60, it is 3 by 5. Probability of A is 4 by 9 divided by 5 by 9. There is something I'm doing wrong. Okay, let us try from, did I do any mistake in writing the formula for naive Bayes? No, A by B is B by A, probability of A by probability of B. Is that correct? Probability of B, yeah. Okay, So let us compute this thing again. Yeah. Oh yes, caught the mistake, sorry. Yeah. Probability of students failing. Probability of students failing are 4 by 9. Yeah. And probability of attendance 40 to 60. Attendance 40 to 60 is 5 by 9. Yeah, I'm doing it again. Then probability of uh, attendance between 40 to 60 and such student failing. Yeah. So what is the probability of such student failing already failed? 4. Yeah, there I made mistake. So already failed are 4. I think this calculation is where I made mistake of not considering that A has already happened, the student has already failed, and then what is the probability that their attendance is between 40 to 60. Yeah. So there I made mistake in calculating this probability. So probability, so A condition is failing, right, and B is attendance between 40 to 60, right? So student failing, how many students are failing? 4 students are failing, so that will be the denominator. And out of 4, how many students have attendance between 40 to 60? 3. So this will be 3 by 4. Yeah. So now let us put this thing into, so 3 by 4 multiplied by probability of A 4 by 9 divided by probability of B 5 by 9. Okay, so this 4 gets cancelled. 3 by 9 will bring it to denominator, the cross multiplication. So 9 goes, this is 3 by 5. Yeah? So answer to this question is 3 by 5. And in a straight way, without using conditional probability equation, how we can do this is, there are total 5 students who have attendance between 40 to 60. Out of them 3 are failing, so straight away it is 3 by 5. And even the conditional formula also, this conditional probability formula, the Bayes theorem formula, also gives us the same answer. Only point which you have to keep is the event order, the condition order, right? So that's why here what the mistake I made was, I considered only this 4 students. So what I did was, I considered that B has already happened, the attendance between 40 to 60 has already happened, but we had to consider that failing has already happened. So that's why here denominator will be 3, and out of them how many have attendance between 40 to 63. So this is the condition probability, that what is the probability that attention between 40 to 60 and the failing. Yeah. So for this particular question, Ria, there is no need to do this conditional probability, but I'm explaining, if for benefit of broader audience, like if you want to apply the formula, then you should know how to apply the formula, how to calculate these probabilities. Yeah. Otherwise there is no need to follow this formula, this particular formula, condition probability. Here, by simply looking at these values, you can say that we are asked that what is the probability of student failing the exam if their attendance is between 40 to 60. So we will count how many students have attendance between 40 to 60, total 5. Out of 5, how many have failed? 3. So the answer becomes 3 by 5. That is how it has come. So there is no need to take this long cut, but still, since in the question it was asked that apply naive Bayes classifier, so we applied naive Bayes classifier. So now the second question is, what is the probability of student passing the exam So this becomes our event A, passing the exam if the attendance is between 70 to 80. This is the condition B. So probability of A given B has occurred, that attendance is between 70 to 80. Then this is the formula, probability of event B when A has occurred multiplied by probability of event B divided by probability of event A. So now event A is passing. Event A is passing. So how many of students have passed? 5 out of 9. So this probability is 5 out of 9. So probability of A is 5 out of 9. Now probability of B is for attendance. Attendance between 70 to 80. So attendance between 70 to 80 is 1. So this 1 out of 9 student has attendance between 70 to 80. So this is the probability of B. So now probability of B minus probability of B when A has occurred. So passing has already occurred, and how many students have passed? 5. So out of 5, how many students are between this attendance 70 to 81? So this will be 1 out of 5. So let's put all these values into formula. 1 out of 5 multiplied by probability of B, which is 1 by 9, and this is 5 by 5 by 9, and this is again 1 by 9. 1 by 9. So this gives us 5 gets cancelled, 1 by 9, cross multiply 9 by 1. Everything went, huh? This also? No, this is still there. So passing is event A, attendance between 70 to 80 is event B. So probability of A given B has occurred is probability of B given A has occurred multiplied by probability of B attendance between 70 to 80 divided by probability of probability of passing divided by probability of attendance between A and B. So what is the probability of passing? How many students have passed? 5 students out of 9 have passed, 5 by 9. Yeah. And how many students have attendance between 71 to 80? 1 student, 1 out of 9. Probability of B by A. What is the probability out of all passed student? How many students have passed? 5. And how many have attendance between 70 to 80? Is 1. Yeah, from that table, frequency table, this is what we have gotten. So now we have all the values. We'll put those values in this formula. 1 by 5 multiplied by 5 by 9 divided by 1 by 9. This 5 gets cancelled, so 1 by 9 divided by 1 by 9, do cross multiplication, final answer will be 1. Yeah? So this is the final answer. So now how to do this without applying this particular formula is, we will focus only on this particular column, this particular row here, attendance 71 to 80. The question asked is, what is the probability that student will pass if the attendance is between 70 to 80. So how many students have attendance between 70 to 80? 1. Out of these 1, how many students are passing this 1? So this becomes 1 by 1. So without putting this in formula, just by looking at this frequency table, we can answer this question. Yeah. So in the same way we have done previous question also, Shrija. The way in which we have done this question, we have done same way. How many students have probability between 40 to 60? Total 5 students. Out of them, how many have failed? 3 students. So this is the answer, 3 by 5. And this is the formula which we have used, but there is no need to apply this formula. You can actually do this by looking at the frequency table. So question number 4 is based on the theory part, or the points which we have to remember for decision tree. So when to stop further constructing the decision tree. Yeah, so I am expecting answers to this question in the chat box, that when we will decide to stop constructing the decision tree, or when we will decide that we have reached the leaf nodes. So option 1 says there are no more conditions left. Option 2 says there are all the conditions belong to one group. Option 3 says when most of the conditions are grouped, leaving a few ungrouped. And option 4 is when there are odd numbers of node remaining. So this doesn't make sense. Odd numbers of node remaining. That is no logical point to stop constructing the tree. And another statement which doesn't make sense is statement number 3, that there are few ungrouped. Why would we leave any ungrouped data points while we are constructing any decision tree? We will not stop if our ungrouped data items exist. We will stop only when all the conditions are met and all the data points are grouped. They belong to one group. All the conditions belong to one group. Yeah. So the correct statement is option 1 and option 2. When there are no more conditions left, we are taken care of all the conditions while making the branches of the tree. And when there are certain conditions which belong to one group only. So you think of this in terms of hierarchical clustering, there agglomerative clustering. When the distance between the neighbors was not much, then we were not subdividing it. We were considering it as one group only. So the same logic applies here, that when all the conditions, we can put it in the one group. So in other words, if the condition is based on how many marks a particular student has gotten in a mid-semester exam. So we have two conditions, greater than 50 and less than 50, and we have hundreds of students, but we will go through each data point and then we will check for this condition, greater than or greater than 50, less than 50, and then these two and we will divide them into so at that point we'll branch the tree. So all the marks which are greater than 50, they will be part of one branch, and all the students where the marks are greater than 50, they will be part of another branch. So this is how we are grouping the condition. All the conditions we are grouping, that marks greater than 60 will also be part of marks greater than 50. Marks greater than 70 will also be part of the node marks greater than 50. Marks greater than 80 will also come under marks greater than 50. So this is how one condition which will be consisting of group of or subgroup of different conditions. So when all such conditions are grouped under one bigger group, so then we will stop there only, that we are taking care of all the conditions where marks are greater than 50. So we will stop it there, and other branch will be marks less than 50. So less than 50, that will comprise of less than 40 also, less than 30 also, less than 20 also. So we are considering all these conditions in that one particular branch. So that's one logical step where we can stop further branching. Okay. So now I'm going to read the questions asked. What will happen when question MSQ type radio button? No, it will be same only. That's the square and circle. If there is circle, that means only one option correct. If there is square, then there are multiple options correct, because that's the drawback of HTML programming language. It has nothing to do with the which how you are doing it. Okay, so that's one hack, that if there are more than one answer correct, then you will see the square button and not the circle button. Okay, we are classifying. Then how in one group? We are classifying, so we are considering conditions. Yeah, so conditions would be how much marks a particular student has scored. So if our condition is dependent on that one feature, that student's marks, so one condition which we can generate is greater than 50, less than 50. So that's, we are classifying our data points. So what we are classifying is data points, and how we are coming up with conditions is based on the set of features which we have, based on the set of independent variables which we have. So based on this set of independent variables, we had this one feature of students' marks. So we came up with this condition of greater than 50, less than 50. So how to come up with these conditions? Through entropy and information gain. For more information on entropy and information gain, please go and watch the video. Okay, videos on decision tree. Ram sir's video, the course video, he has explained very nicely how to consider this entropy and information gain. Again, this is the game of probability, so you have to come up with an extensive frequency table. You know how many data points are justifying that one particular condition. So we can come up with any condition for this decision tree. You know, that condition is up to us. So we will calculate, we will decide where to put our conditions, or how to consider that condition based on information gain and entropy. So maximum information gain is how we choose the condition. If there are supposed to be 10 conditions for score, like greater than 90, then greater than if it is greater than 90, then it will be again subdivided that between 81 to 90 and less than 80. So then again that less than 80 tree will be again subdivided between 71 to 80 and less than 70. So that is how we are considering one umbrella condition of greater than less than 90, and there will be subdivision of that thing. Okay, so right now it may be I don't know if I have cleared your doubt or I have created more confusion, but this is how, you know, if you remember that hierarchical clustering, so consider same example to understand this decision tree also, because in the same way we are doing this decision tree as well. In hierarchical clustering, we were considering distance between the data points, distance between these features. So in the same way, here we are considering which condition that particular feature is satisfying. So marks is, so one thing is that one same condition which I gave you example was, if there is a divide at 50, greater than 50 marks and less than 50 marks. So we could, less than 50, we could that the umbrella condition will also have all the data points which are less than 40, which are less than 30, which are less than 20, and greater than 50 will have all the another sub conditions, greater than 60, greater than 70, greater than 80, greater than 90, and so on. Okay, great, thank you. Because I was confused whether I'm confusing you or clarifying you, so I needed this thing from you. Yeah, so that's the meaning of this, you know, conditions belonging to one group. Coming to question 5, why is the naive Bayes classifier called naive? So yeah, this answer you all will give me. I'm going to take few seconds break here. You please read all the options and tell me which option is correct for this. I'm going to drink some water here. Yes, absolutely correct. That naive assumption that all the features are strongly independent, they don't interfere into each other or they are not influencing each other, is a very naive assumption. Yeah? So that's why it is called as naive Bayes classifier. Yeah. So question 6 is decision tree is non-linear classifier. Is it true or false? It is true. Yeah, it is non-linear. Only the linear logistics, linear regression, not linear logistic, linear regression would assume that there is a linear relationship, and it will it will create the model around that assumption of linearity or linear dependence between the variables. But apart from that, decision tree is a non-linear classifier. It doesn't assume linear relationship or anything. So to question 7, overfitting and increase in tree complexity we can overcome through the process called as pruning. Very nice. I'm getting all the answers in the chat box. So we have actually, yeah, we covered this in very detail when we were looking at the points in the beginning of today's session. So coming to question 8, which of the following is advantage of decision tree algorithm? Yeah? It is extremely fast. Second, it is easily interpretable and explainable. Third, it can be used for classification, clustering, as well as regression analysis. Third, it can be used for sequence mining. So fourth is definitely not. Yeah, decision tree is not used for sequence mining, because we are in sequence mining is totally different thing which we saw during diagnostic analytics week, that where we try to mine for, or where we try to look for sequence of actions or a set of actions which occur frequently in the log data. So that's the sequence mining. So 4 is definitely not. Option 1, 2 and 3, out of these 3, which is the correct statement? Okay, so there seems to be some confusion here. So when we use it for clustering, we don't call it decision tree. So don't get confused. So the question is about decision tree, but as soon as we limit it to only clustering, then because the whole point of doing clustering is very different than having a classification or prediction algorithm. Okay, in clustering what we are trying to do is we are trying to group some similar data sets together. Yeah, so this technique is not classification, right? So don't get confused between classification and clustering. So even though decision tree is very similar to hierarchical clustering, it is not hierarchical clustering. Yeah, because hierarchical clustering we assume only limited number of features when we are considering the distance between the data points, right? But in decision tree we can consider all the conditions, all the features, multiple features, there multiple conditions, all that can be considered while coming up with this decision tree. So that's how this clustering and decision tree are different. I was telling you that they are similar because the way of implementation is similar. The tree, starting from a root and then going and branching, creating branches. So this way is similar, but it is not clustering, because in clustering we try to compute the distance between the data points. So that distance is nothing but the values of features, right? But here we are not considering relative placement of our data points. Here we are considering what conditions those data points are satisfying. Yeah, that's why don't get confused between this thing. Even though the way of implementation is simple, this is not clustering. So that's why this option 3 is not correct. I hope I have addressed the misconception here. All those who have answered option 3 as correct answer for this question. Everybody agrees that 3 is not correct in case of decision tree algorithm. It is not the advantage. So Shrija, what point you did not understand? I will repeat only that point. there could be some problem that some why you can unmute and say tell me that why you think option 3 is correct, and then I can probably I will be able to address your doubt better if you let me know what is your thought about this option, no? Because repeating everything will not help clearing up your doubt, Shrija. That's why I'm asking you to unmute, or if you're not able to unmute, you can type in the chat box that why you think option 3 is correct answer. That is also fine if you type in the chat box. Okay, I'll give you some time to gather your thoughts, and meanwhile let's check out statement 1 and 2. So statement 1 says extremely fast. So will this be true for a decision tree algorithm? We have seen that decision tree is a greedy algorithm. It will look at every data point, every feature of every data point, and it will try to fit in or create a condition for every feature and every data point. So this cannot be fast. So this is also wrong, because when you are considering every data point, every feature, and when you're trying to fit in or when you're trying to create condition based on that feature value for every data point, then you're bound to be slow. Yeah, because you're going into such a detail for every data point, every feature, you're considering every value to branch out, to create new leaves. So that means you're spending too much time. So when you're spending too much time onto creating on branching, you cannot be fast. So this is not fast algorithm. Okay, when we say decision tree is a greedy algorithm, that means it does not pay attention, or the priority of that algorithm is not to be fastest, but priority of that algorithm is to be accurate at the very low level, at the very every minute level. That's why it will not be fast algorithm. Now it is easily interpretable and explainable. Why we say that? Because the conditions, there are conditions which are based so this branching is decided on the conditions, right? So branching in this decision tree is decided on the conditions. So we know at what condition value, if it satisfies, it will be part of branch to the left. If it does not satisfy, then it will be to the branch to the right, and so on. So it is explainable. The construction of tree, every condition is stated at this level, so this condition, the branching level, every condition is stated. So it is interpretable and explainable. So this is the major advantage of decision tree algorithm or ID3 algorithm. Yeah, so this is another name for decision tree algorithm. So this is the biggest advantage of having the classification tree or decision tree classifier, is to when we can understand how this classification has occurred, which conditions were taken into account. So that leads to interpretability and explainability. So not all machine learning algorithms are interpretable and explainable. So that's why it becomes advantage. We saw regression also last week. It was when we feed that regression to some softwares like Orange or Veka, which are available for machine learning. So at that time, it will not give us the equation which they have followed, but they will give us the root mean square error value and accuracy value, and so on. So that's why we that's the importance of understanding the root mean square error, or the concept of error and all those things, so that we are able to interpret the result of such thing. But if you choose the decision tree algorithm in Orange or Veka, when it will give you the result, it will also show you the decision tree, the conditional tree which it has created. So that leads to explainability and interpretability of algorithm. Okay, so going to question 9. Question 9, it is saying that suppose you have given the following graph which shows ROC curve for two different classification algorithms, random forest and logistic regression and KNN. Now, which of the following algorithms would you consider for your final model building on the basis of performance? So we had seen similar question in again that week 3, where we had seen the KNN, when we had seen um, the parameters, you know, the accuracy and precision, all those parameters we had seen. So at that time we had seen this concept of area under the curve or ROC curve, how to interpret it. So the basic concept of that was it has to be closer to the 1. The value of area under the curve has to be closer to the 1. So as close that value is to 1, that algorithm is better. Which has the largest ROC value is the better. So in this graph, can you tell me which will be the best suited or most based on the performance, which algorithm is better? This blue line, because area under curve is 0.94, compared to other area under curve, this value is the largest. And can you tell me which comes the second? Second comes this green, which is corresponding to KNN, because it has value of 0.91. And then the last is this logistic regression. This particular line is called a reference line. This gray line, the dotted line, is called a reference line, which is x is equal to y line for 1 1. Yeah. So any line which lies above this reference line is good fit, and any algorithm which has this ROC curve below this reference line is a bad fit. Yeah. So this we had already covered, so I am repeating it as revision. If this value is not given, then the line which goes to the farthest or which goes to the closest to this line, these two lines, maximizes area under curve. So if some line goes like this, then this line would be the best. Okay, but for given parameters, for given question, this blue line or random forest is the best performer here. Okay, yeah, thank you, Shuja, for typing. I'm going to read out for everyone's benefit, and we can go back to the statement. Yeah, I think clustering is used for grouping the data points. Absolutely correct. Clustering is used for grouping the data points together to create limited number of groups. So we have so what happens in clustering is we have certain target that we are supposed to create. We are supposed to create some 4 groups or 5 groups or 3 groups or 2 groups. So that number of groups is we can fix how many groups we want in the beginning when we are doing some clustering exercise. Yeah, so there is so you're saying that clustering, you are confused between clustering, classification and regression. So regression is prediction. Okay, so regression is the machine learning word for prediction. Now clustering is a exercise where we are considering distance between the feature, the difference between the feature values of the data points. And in classification, so what happens in clustering, that at one point we can consider only one type of feature when we are measuring the distance, right? So that limits our so clustering is nothing but limited decision tree. Yeah? I'm not saying they are different or they are opposite to each other, they are not the same. It's not the case. The case is that clustering is very much part of decision tree. Construction of decision tree is based on similar way in which clustering is implemented. So the way of implementation is same. Yeah. So when we consider one feature or yeah, we were here only. Yeah. So when we consider only one feature for creating condition, we are doing clustering. When I'm considering only marks, so all the students who have scored greater than 50 will be branched on this side, greater than 50, and this will be less than 50 and greater than 50, so on. So we are grouping here, we are clustering for one condition, right? And if we are going deep down, then we are doing this clustering again to the sub level. So this is clustering. So clustering is for one condition. But in classification, we are considering all the features, the multiple features. There could be more than one features. So this one tree which is for one feature, which we can call as cluster. So when we are combining multiple such clusters, or when we are implementing multiple such clusters together, we are doing this decision tree. That's the difference. Is this clear now? So the way of implementation is similar for classification and clustering, but the purpose is different. Yeah, or the bigger goal is different. Okay, great. Yeah. So this way, if you are vocal about where exactly you have trouble understanding, we can have better one-to-one sessions. Okay. So don't be shy of speaking up or unmuting and talking. If you can't unmute, then please feel free to type in the chat box. I make sure that I address every doubt which has come in the chat box, and this is the whole point of having this session, so that all the things which cannot get clarified then and there, while you watch the videos for that particular week, we can address those points here during these sessions. Okay. So I'm looking forward to such interaction, Shrija. So whenever you have doubt, if you cannot unmute, please type in the chat box. We will address. I will try my level best to address all the doubts. So we have reached to the end. This was the last question because there was 3.1 and 3.2. Yeah, so there were two questions based on that Bayes theorem probability. So question 9 was last question. There are no more question left. So if we are done for this session, today's session. So if there are no more doubts, or I will wait for some doubts. Yeah.
Ma'am?
Yes, yes.
Yes, ma'am. One thing just I wanted to clarify whether my understanding is correct. So in decision tree, basically there will be multiple decision,
Yeah.
right? So under one decision, we are grouping similar items.
Yes,
Is it
yes.
correct?
Yes,
And
yes.
the second decision, it will be clubbing into some other observations, right? But
Right.
under clustering,
Right. So like let us consider this example only, attendance and passed in exam. So here there is only one feature, attendance. Based on that, we are trying to predict whether student has passed or failed. Yeah. So what so if there is if we introduce some another feature or another variable, say performance in project. Yeah. So what we will do is we will have, there are three branches here for attendance. There are three groups, right? So there are three conditions. So this could be the main condition, that greater than 60, less than 60, and then it will be again, no? Why? Because less than 60 there is only one condition, 40, 60, this will be here, and then greater than 60 will be 61 to 70 here, and 71 to 80 here, something like that. You understood at this one point there is one branching, and at this point there are two branches created. So
yes, ma'am.
so
Yes,
this
got
is
it.
how we are doing it.
Yes,
so,
yes.
so this was for one condition. So now if we are introducing other condition also, performance in project. So for when we evaluate marks, that we find that marks are 55. So the algorithm will come to this point here
Yes.
in this branch, and at this point we will evaluate that what is the relationship between performance in their project, whether they have scored 10 out of 10 or whether they have scored 5 out of 10. So based on that, there is further branching will happen for prediction of pass and fail.
Okay.
Okay, so when we
Yes.
will stop, so what do we mean by we will, all the conditions are met, then at that time we will stop. So what do we
Yes.
mean by that is, this is the very good example here. The attendance of student is between 71 to 80%, and all such students are passing. So we will stop here. We will not divide this further. 71 to 80, we will not divide it further. They are all passing. So that means all the conditions are met.
Same group.
Yeah,
Correct.
so they
All
are
observations
all,
are pass.
yeah, so they will be part
Okay,
of
got
this
it.
one group or one
Yes.
cluster.
Yes.
Yeah, so that's the difference between cluster. So in clustering, we would not have thought of branching it further based on some other feature value. We would have stopped it there itself in clustering. But whereas in classification, we are considering other features also. Yeah, so that's the similarities and difference between classification and clustering.
Okay, ma'am. Thank you.
Can you please previous week class as summary? I didn't understand, Ria. Can you unmute and say what you want to say?
Well, actually, previous week I attended class. So can you please
Oh, okay. So what I will do is I am going to give you link of previous week's recording, session recording. Yeah. So you can actually sit through this YouTube
Yes,
video.
ma'am, I have already seen the YouTube video, but some problem is there in existing equation, interception problem.
Oh, intercept problem is very similar to that of what we do in our 10 standard statistics. That equation, you just have to remember the equation. This is the line equation. Now y is equal to say mx plus c. So how we will find the y intercept? We put x is equal to 0. X is equal to 0 if we put, then what value you will get if x is equal to 0, you will put is y is equal to c. So c becomes the intercept value and m is slope. This is a simple line equation. So these are the straightforward formulas, Ria, which you will have to either remember logically like this. How we come up with this intercept is we substitute x is equal to 0, and then whatever value for y we are getting is y intercept, and m is the slope value.
For question numerical problems, is there will be set the C value? Final
Sorry?
question.
Yeah, this formula will be given. The regression formula, the linear regression formula will be part of question. So in previous week also, it was part of question. In the question only, this information was given. What is the formula for regression which you have to follow? That will always be part of question. In fact, last week was very nice and scoring week in terms of the numericals. All the numericals were there, like majority of the questions were of numerical types, and they were quite easy to solve. So I would suggest don't leave a previous week out of practice. Practice, make sure you solve the questions. So you will notice that if you go through this YouTube channel, so I conducted live session for last year also. So you will find last year's interaction videos also uploaded on the same YouTube channel. So if you want more practice or more revision, you can go through those videos also. So last year we have solved last year's assignment questions. So they were little different kind. Many of them were common also. So you may find some new information or some new type of question in last year's videos as well.
Okay, ma'am. And where we can find the previous year final question? Can you please share that?
Sorry, can you speak little louder?
Final question of previous year. Can you please share it?
No, so question paper is not shared generally. So I will not be able to give you the final year, so the final question paper. But the assignments, you can go through the video recordings. They are uploaded on the same channel. Last to last years are also uploaded. You can go through that, and maybe in next week I will also share the the PDFs folder for last to last year. Yeah, so I use these PDFs, no, where the questions are there, options are there, in this format, the questions and options and the correct answer, correct option ticked. So in the same format, the PDFs, all the 12 weeks PDFs are there for last week also, last year also. So that folder, remind me to share with you. I will keep that handy for our next week session. Okay. So next week I will share these such PDFs where I have solved the questions there and marked the correct option here, like that. So that I will keep that link handy, because now I'll have to look for that thing. Now it will take time, and I do screen recording also to upload these sessions on YouTube. So what I will do is next week I will keep that link handy, and I will share that folder also with you all. So you will have access to last year's questions also, last year's questions also, and this year questions you all are solving only as part of your assignment. So you will get plenty of practice. So for entropy solving, use the formula of entropy. Let us check my memory. Yeah, correct me if I make mistake in entropy formula, because I don't ever by heart the formulas. I'm very bad at by hearting formula. I can't. I just try to remember. Yeah. C is number of classes or conditions. Yeah. So this base, this is important. Log to the base. This base is can somebody confirm that this formula is right? I think there's negative sign somewhere here.
Yes,
Entropy.
ma'am. Negative
Yeah?
is there.
Yeah, negative, I forgot. Yeah. So negative sign. So this is the formula you have to use. So what is the probability of how many classes are there in that? So if there are, suppose, 2 classes, pass and fail. Yeah, this is classifier algorithm, right? So there will be classes. So there will be 2 classes, pass or fail. So this we will be this formula will consider log to the base 2. So for all from I to C, we will do this condition for all pass and for fail. What is the probability of pass? Then log to the base 2 to the probability of pass. What is the probability of fail? Then log to the base 2 of that particular value, and you have to multiply that, and then don't forget this negative sign. That will be, so minus A plus minus B, something like that you will get, which will be minus A minus B. So ultimately you are adding all the values, and there will be negative sign up to that. So this you will have to, so it's a mathematical operations you have to do. You have to do it for all the class. Yeah, pass, fail, calculate the probability, calculate log to the base number of classes. So generally number of classes are 2 only. So for all the, for attendance also, attendance greater than 50%, attendance less than 50%, 2 assignments solved, greater than 2 assignments solved, more than 2 assignments solved. So likewise there will be generally 2 classes. So you will have to find the probability of a student belonging to that particular class, and then log to the base of 2, then that probability. So this value, so this is the entropy formula. And information gain formula is, I think, again some summation SV minus SV upon S, and then minus entropy, something like that, minus entropy. I'm not sure about the formula. Somebody please confirm this formula.
It's entropy of S minus
Entropy
summation.
minus, yeah.
Entropy minus summation of that class divided by total, SV divided by S
Yeah, SV and
multiplied
something
with entropy.
again entropy here, na? Yeah.
Yes,
Huh.
yes.
So this I was remembering entropy and minus entropy, or that entropy I was not. Yeah. So entropy you will calculate using this formula. Then SV minus S is within that formula. So there would be some predictor variable and there would be some independent variable. So generally information gain we will be calculating for independent variable. Yeah. So within that independent variable, say for example attendance less than 50% and attendance more than 50%. So SV minus S is SV upon S is number of students in that subgroup, that attendance less than 50%. How many students have attendance less than 50% is S, number of data items satisfying that condition. And SV is out of those how many are pass and how many are fail. So there will be two classes, pass and fail. So SV upon S value will be for twice you will have to calculate for each subgroup. So this is the SV upon S in this. Otherwise entropy you know how to calculate now. So put this value here and multiply it by entropy minus that entropy. Another this thing is another trick to do this is based on this probability value, pi value, there is this entropy curve. So this is the probability value here, p value. So if p is 0, probability is 0 or probability is 1, then this entropy value is 0. This is entropy here and probability on x-axis, entropy on y-axis. So this graph you will have to remember. So these are the points, like the minimum value of entropy as probability is 0 or probability is 1. So if this value becomes 0 or 1, then the entire entropy value becomes 0. And if probability is 0.5, then entropy is maximum 1. So entropy is nothing but how variable your data is. Yeah, how what is the, so if you all remember what the purpose of standard deviation in the data, what is the variability in the data, you know, the same way entropy is also variability in our data set. Yeah. So if the probability that all the amount of uncertainty, so this entropy is that if all the data points are belonging to one particular class only, so then there is uncertainty or variability in our data set will be minimum, right, which is 0. And if all our data points they would belong to only one particular class, then probability of that particular class is 1. So uncertainty in the data set or the variability of the data set, it again goes that all the data point are belonging to that one particular class, then entropy becomes 0. And if there is equal probability that our half of our data points are belonging to class A and half of our data points are belonging to class B, so there are equal chances that any data point randomly you pick up, it will be belonging to class A or class B, then at that point our entropy or uncertainty in our data uncertainty will be maximum, which will be 1. Entropy value would be 1. Yeah, so this curve you remember, if your pi value is 0 or 1 or 0.5, then you can calculate this entropy value. And if entropy value is 0 or 1, your information gain gets impacted likewise. Okay, so it's very easy. Go through the videos of Ramsar or any to see how to solve this such type of problems. So SV by S is nothing but what is the probability within that particular class. That's it. ROC we have already covered this in I think week 3 or week 4. I don't remember exactly which week. You can go back and check the content of that week to understand what is ROC curve. Because to now to explain ROC again, we'll have to start with precision and accuracy. That will take too much time, that itself will require more than half an hour. Yeah, please, if you anyways you will have to revise, so start revising. Give some time to every week go through the lectures, lecture notes, the presentations of every week at least, and keep yourself updated. That repeated revision will not let you forget the new words which you have learned in this course. So I know that ROC, accuracy, precision, all these words are very new to all of you. So one way to ensure that you remember all the formulae and everything is that to go through um, the lecture notes or the PDFs which I share periodically, so that you become well versed with the terminology of this course. We have discussed this ROC in that week when it was happened. I think it was week 2 or week 3. I don't remember. I think it was week 3 where we had seen accuracy, precision, ROC curve, and all those parameters, the performance matrices, performance metrics. It was part of that performance metrics. So, any more doubts? So if there are no more doubts, we will close this session here. Yeah. Okay, see you all next week. Next week will be week 10. And NPTEL would be floating a survey for revision class. I'm not sure if they're going to do in this run. So if you want extra session after 12 weeks, feel free to mention so in that survey or in the discussion forum of the course, so that we can plan accordingly if you need some extra revision session or extra doubt solving session. Not revision, it will not be really possible for me to cover all the 12 weeks content in a couple of hours session, so we'll call it doubt solving session. So if you need that extra session, we'll have to plan that beforehand. Okay, so see you all next week. I'm closing this session for now.
Thank you, ma'am.
Yeah, thank you.